Hey guys, welcome to Creative Biology. Here I am with another video on the amino acid and protein. In this video I am talking about the titration of amino acids. So first of all, when we titrate the solution of these amino acids that have a neutral charge, or we can say is at the pH equal to its isoelectric pH, with an titrant solution of acidic or basic nature, so at that time that molecules either get positive or get negative charge according to its ionizing group, or we can say the changes in the charge on their ionizing group present it here and here. So here in the simple amino acid, that is an COOH, and NH2 group, that is an that having the ionization capability. So before going on to titration, first we need to understand the term that is an Zwitter ion that I already explained in my first video. If you haven't seen that, just go and check out that video. So if we titrate the solution with an acidic solution or acidic titrant, so in that case the pH will decreases, and ultimately that molecules get positive charge. And why it get positive charge, that is also I explained in my first lecture, right? So please go and check out that video. So the changes in the pH at that time, that is an pK1, that is in case of alanine is 2.34, and when we titrate this type of the solution with an basic titrant, so at that time it will get the pK2 value is equal to 9.7, right? So if you have to calculate the pi value from these two value that is given in your exam, in your equation, so in that case you have to use one equation, that is an pi is equal to pk1 plus pk2, that divided by 2. So here in this case, that is in case of alanine, you have the pk1 as an 2.34 plus pk2, that is a 9.7, divided by 2, so it will get approximately 6. So yeah, it's as simple as you can see here, that pi value is easily calculated using this equation of non-polar amino acid, right? But in case of the polar amino acid, or we can say then charged amino acids, in that case then amino acid that contain the acidic or basic nature, or we can say is a more ionizing group, as in case of this glutamate, right? So here it get the another COOH group, or we can say the ionizing group present in its R chain. So in that case that pi values calculation is not as much easier as in case of the alanine. So here, as you can see here, that at the pH, or we can say is the pH is equal to its isoelectric pH, so in that case it have no charge, right? Because it's in the form of this Zwitter ion. When we titrate it with an acidic solution, it get the positive charge, because the COO minus group accept an proton and converted into the COOH. So at that point that pK1 is 2.19. But if we titrate it with an basic solution, so in that case it will see here that an second ionizing group, that is an present in the R chain, will donate its proton and convert it into the COO minus group. So here, as you can see, that molecules get the -1 charge. Here that molecules have 0 charge, and in this case that molecules have the +1 charge of this group. Okay, so if we titrate further, then if we titrate further with an basic solution, so in that case that amine group also deprotonated and converted into the NH2, so it molecules get the -2 charge, or we can say the -2 means that -1 of this group and my second -1 of this group, so it get the -2 negative charge. So in that case the case pK2 is equal to 9.67. okay, but if you have to calculate the pi value of this type of molecule, then how you can calculate? See, if you simply take that pK1 and pK2, you are unable to calculate the pi value, because that gives you a wrong answer, because in case of the acidic or basic polar amino acids, right, so in that case you have to calculate the pi value with another equation or simply modification of this equation. Let I explain you. When you calculate the pi value of acidic amino acid, as in case of the glutamate, or we can say glutamic acid, so in that case you have to consider the p1 as an pK value of acidic side. So here that pK1 is as it is, so that pK1 in this case is an 2.19, and pK2 as your we can say that second, or we can say centric pK value. So here you count the pK2 as n4.25. so in this case that pK1 plus pKr divide by 2, that gives you the value of pi. okay, but in case of basic amino acid, let's take an example of histidine. So in that case also you get this type of equations. So in that case you have to take the value of pK1 as an pKr and pK2 as an pK2. okay, let's consider this as an histidine. So in that case you have to calculate the pi value with the pKr plus pK2 divide by 2, and that value gives you the pi value. So that's all about the basic concept behind this. Is if you have the acidic polar amino acid, then you have to consider the pK1 as your acidic side pK, and if you have that basic amino acid, then you have to consider the pK as and your acidic side pK value. And this pKr is remain as it is in the both cases, as you can see here, right? In both equation pr is calculated or used, but in case of acidic you have to use the acidic side of pK, and in case of the basic amino acid you have to use the basic side pK value. okay, and that's all about for today's video. In next lecture I am going on the peptide bond formation, so stay tuned.